Good day, my audience. Today we are going to look at binomial theorem. In binomial theorem, we have series of examples that I want us to pay attention to. We're going to start with the number one, expansion, and we continue. So we are going to look at how to expand x plus 7 all to the power x plus y, all to the power 7, okay, using the binomial theorem. Now, remember that in the binomial theorem, all we do is to make use of the binomial coefficients when the when we have x plus y raised to power n, where n is a positive integer. If n is a positive integer, we make use of the binomial expansion x plus y raised to power n to be nc0. This is the binomial coefficient. We have x raised to power n, y raised to power 0, plus nc1, x raised to power n minus 1, y raised to power 1. We continue in that manner until we have ncn, x raised to power 0, y raised to power n. Okay, this formula works only when we have n as a positive integer. So right here we have n as a positive integer, n here is equal to 7. So we're going to make use of the binomial coefficient. Now, most of the times, students go ahead using the Pascal triangle, which is also a replacement of the binomial coefficient. The binomial coefficient has the formula NCR equals to n factorial over n minus r factorial, r factorial. And by the time you finish evaluating this, it could really take a little time, more time to evaluate before you input the coefficients, before you input the results from the formula which you calculated into the space where the coefficients are. Is going to take a little bit longer. So what students do is to use the Pascal triangle, for x, okay, for x plus y raised to power 7, starting with 1, you have 1, 1, okay, you have 1, 1 plus 1 is 2, you have 1, you have 1 here, 1 plus 2 is 3, okay, you have 3, and then you have 1 here. Here you have 1 again, 1 plus 3 is 4, you have 6, you have 3 plus 1 is 4, you have 1, you have 1 here, 1 plus 4 is 5, you have 10, then you have 10 again, you have 5, and you have 1. Okay, here you have 1, 1 plus 5 is 6, you have 15, you have 20, you have 15 again, you have 6, and then you have 1. Okay, finally for x plus y raised to power 7, you have 1, you have 7, you have 21, you have 35, okay, you have 35 again, you have 21, 7, and 1. Now the last one is what we are going to use, which is the binomial coefficients for x plus y raised to power 7. This is the binomial coefficient for x plus y raised to power 6. This one is for x plus y raised to power 5, and so on. So we are going to use the formula x plus y raised to power 7 to be the first coefficient, replacing the binomial coefficient nc0, 7 c0, x raised to power 7, okay, y raised to power 0, Okay, we have plus 7c1 x raised to power 6 y raised to power 1. Okay, we continue, plus 7c2 x raised to power 5 y raised to power 2 plus 7c3 x raised to power 4 y raised to power 3 plus 7c4 x raised to power 5 y raised to power 2 plus 7c5 x raised to power 6, this is x raised to power 3, and this is y raised to power 4, because as x is decreasing, y is increasing. This is x raised to power 2, y raised to power 5, plus 7c6, x raised to power 1, y raised to power 6, and lastly, 7c7, which is x raised to power 0, y raised to power 7. Now, instead of evaluating these binomial coefficients one after the other, what we do now is to use these numbers. 1, in place of 7c0, we have 1 times, 1 in brackets, x raised to power 7, y raised to power 0 is 1, plus 7c1 will be 7. If you evaluate it, you have x raised to power 6, and y raised to power 1. And then, of course, this one, the 1s are gone. Here, this one is 1, and this one is 1. 1 times 1 times 1 is 1. So that's what we have there. Then the next one is 7c2, which is 21. 21, 7c2 is 21. And this is x raised to power 5, y raised to power 2, plus you have 7c3, which is 35, x raised to power 4, y raised to power 3, plus the next one is 7c4, which is 35 again, x raised to power 3, y raised to power 4, plus 7c5, which is 21, x raised to power 2, y raised to power 5, plus 7c6, which is 7, x raised to power 1, y raised to power 6, plus the last one, which is 7c7, and that is 1, x raised to power 0, which is 1, and you have y raised to power 7. Of course, this one is 1. And then you have that the binomial expansion of x plus y raised to power 7 becomes x raised to power 7, 7x raised to power 6y plus 21 x raised to power 5y squared plus 35 x raised to power 4 y raised to power 3 etc. up to y raised to power 7.